Okay, so this is the test review, and I'm basically just going to go over the stuff that's on the test. So let's talk about what a computer is. So first off, I said that a computer is an electronic device, and it's an input-output device. So basically what it does is it takes input, it processes it to output. Now, what is processing? Processing is basically just doing stuff to your data. So if you have Word, for instance, and you make something bold, that's processing. Okay? So, I gotta mark off the topics as I go along, so make sure that I've covered stuff. Now, so we said that a computer is an input-output device, and it takes input and it processes it to output. We have different kinds of computers. We have laptops, we have desktops, we have smartphones. And by the way, a smartphone is, or you could consider a smartphone to be a computer. It also has a camera. So you consider it to be a camera. Ooh, let me get my camera. We actually get our smartphone. So you can take video or still photos. And it's also a storage device, because you can store information on it. Now, when we have small devices like an iPad or a smartphone, those kind of computers don't have a lot of storage capacity, a lot of memory to run programs. So in the future, what we're going to be doing is we're going to have, and even now, we're going to have more and more programs that are in the cloud. It's called cloud computing. So basically it's like you log into Windows 365 and you can run that application from any computer that you're at. No matter whether that computer has enough memory or storage to actually hold the program on its own. You just run it through the internet, through the cloud. The other thing is, when we don't have a lot of storage, that we have cloud storage, and we all have some kind of cloud storage already, because you have phones that have backup capabilities. So you have Google Drive, iDrive, etc. Those kind of online storage devices. So that's important when it doesn't have, when a device doesn't have a lot of memory or storage capacity, and that's going to be more important in the future. We're going to have more and more stuff that's on the cloud or in the cloud, which basically just means the internet. The other thing is that a small device like this, like an iPad or a phone, is made usable because we have a pointing device kind of built in. We have touch screens. So without a touch screen, we basically would all have flip phones, and then you'd have to use, keys to navigate. So a touch screen is very important, especially getting small computers. Okay. What else do we have? So I said that a computer is an input-output device, and we talked about actual hardware and input and output. And there are actually 5 kinds of input, but there's command input, which isn't data input. So we have text, audio, video, and graphics. Those are the 4 kinds of input. They're also the 4 kinds of output: text, audio, video, graphics. And they're really only the 4 things that a computer can work with: text, audio, video, and graphics. So we have input devices. For text, we have a keyboard, or a virtual keyboard using some other kind of, like a touch screen. but it's a keyboard too. We have a scanner. A scanner can input text and graphics. We have digital cameras. We have microphones. So a digital camera can do video or graphics. Microphones can do sound, so they can input that into the computer. Then we have output devices. We have a monitor. The monitor is the most common output device. Even our smartphones and our iPads have monitors built into them. Then we have a printer. We have, well, I guess a display device like an overhead projector, which we used to use all the time when we were in class. Speakers are output for audio. So those are basically, it's not that complicated. We have, you know, input and output devices. We have 4 kinds of things that we can input or output, and that's the hardware. Okay, so when we're talking about digital information, we're talking about bits and bytes. And anytime we have any kind of digital media, whether it's text, audio, video, graphics, the information is represented by what we call bytes, B-Y-T-E-S. Now, in order to understand what a byte is, we have to know the zeros and ones, so bits. So a 0 or 1 is the smallest unit that a computer works with. But we have to combine those in order to represent information or data. So a byte can be thought of as at least 8 bits. And 8 bits, by the way, with 8 bits, we can represent 256 different kinds of or pieces of information. And I always think of a byte as a color or an individual character like the letter A. It just makes it easier for me to understand what a byte represents. And so when I say that a byte is at least 8 bits, if we need to represent more than 256, say, shades of color, then I need a byte that has more bits so that I have more combinations. So a lot of times we use 24-bit bytes when we do color, because that gives us 16.7 million different shades of color that we can represent, or pieces of data that we can represent. When we talk about bits and bytes, we get to megabytes and gigabytes and terabytes. So a megabyte is equal to 1,000,000 bytes and can be thought of as a book. A gigabyte is equal to 1 billion bytes and can be thought of as a 1,500-page books. And a terabyte is 1 trillion bytes. So those are the ones that you should remember. Okay, so what else do we have? Oh, so we talked about bits and bytes. And I said a byte, think of it as a color or a character. I'm trying to make sure that I'm covering everything. So the megabytes and gigabytes and terabytes become important when we're talking about RAM and when we're creating files. So what is a file? A file is we create a file when we save information. So basically, we're saving something. We create a Word document, you want to save it, you create a file. You take a picture, click, it saves the file. It creates the file, it saves it automatically. It's the information that you just captured. Now, the more information with digital media and digital files, the more information that we capture, the bigger the file size is going to be. So for instance, a minute of music is typically about a megabyte. So obviously, if you have a longer song, you're going to have a file that's larger and takes up more storage space. Pictures are the same way. You know, Word documents, if you have 10 pages, it's going to be a smaller file than if you have 50 pages, etc. So the more information that we capture, the bigger the file size. Now, as we move more and more into the digital age, digitizing analog information, and there's a lot of information to digitize, because just think of, say, the Los Angeles Times newspaper has been around for, I don't know, 150 years, 100 years, and they've had, you know, an issue every day. And in the past, there used to be 2 issues a day, the morning edition, the evening edition. Sometimes there'd be a 3 or 4 a day when you had extras. That's called digital conversion. So basically taking analog information and converting it to a digital by using a scanner, that's called digital conversion. Or, by the way, typing it, retyping it. That's the hard way. That's also called digital conversion. So, storage. The most common storage device, portable storage device, is a flash drive. And we said that computers are the main storage device of a computer. Usually is a hard drive. So the hard drive, usually it's internal, it's built in, and there are 2 types of hard drives now. There's the old-fashioned disk kind, and then there's the solid state kind. And we said that the solid state kind is really the future of computing. My new laptop only has a solid state drive. It's 512 gigabytes, but it's very, very fast. So the future of desktop and laptop PC storage, that's going to be SSD drives. By the way, there are no drives in iPads or smartphones. There is SSD memory. So it's kind of like a flash drive memory. SSD memory is very similar to a flash drive. There's a flash drive. Except that the chips are much, 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 much faster. So that's really the future. The reason that we have hard drives is because they are very large and can store massive amounts of data. Next, we talked about RAM, random access memory. So random access memory is the short-term memory of a computer. It's even faster than SSD drives. And you can think of what we use random access memory for just by thinking of how a computer starts up when it was turned off. You turn it on, you wait for the operating system to load into RAM. Once it's loaded into RAM and the operating system is running, then you can start a program like Word. And that's an application program. So any program that you're running gets loaded into RAM. And then you start typing stuff. Anything that you're working on is also in RAM. If you can see it on the monitor, it's loaded in RAM. and RAM stands for random access memory. The rest of this has to do with an internet connection. And we said that in order to have an internet connection, we need an ISP. So we need an internet service provider. And the internet service provider provides us with a connection to them. They have a connection to the internet on the other end. And remember that usually the slowest part of the internet is the connection between us and our ISP. Oh, I forgot the CPU thing. We'll talk about that in a minute. So once we have a ISP, basically what we do is we look at web pages. Well, we do other stuff too. By the way, our connection to an ISP, there are 3 common types right now. There is what we call DSL, which is a digital subscriber line, which uses a telephone line. There's cable, which uses the cable television line. And then there's the future, which is, and now and the future, it's the fastest connection that you can get, and that's fiber optics. So the fiber optic line is the future of internet connections. Now, when we use or want to look at web pages, remember that a web page, every web page has a unique address, and we need a web browser in order to view those web pages. So a web browser is basically just a program that lets you view web pages. Every web page has a unique URL, Uniform Resource Locator. And every web page is a file. It's just saved not on our computer, it's saved on another computer called a web server. So web pages are files, and when you have a file, it has to be stored on a computer, and where web pages are stored, that's called a web server. And web pages are accessed using a web browser. Now, web servers are all over the internet, and we don't really care where web servers are located because the data is traveling so fast that it really doesn't matter whether it's located next door or whether it's located in Nigeria. Information on the internet travels so fast that distance really doesn't matter. Okay, so let's define the internet. The internet is what we call a network of networks. And remember that a network is a bunch of computers that are connected to one another. And the main reasons that we have networks, and by the way, we have networks at school, we have networks at home, and basically it's to save money and to share information. That's the main reason that we use networks. So for instance, at home, you probably have a very rudimentary network, a Wi-Fi network, so that you can share an internet connection and you don't have to pay for an internet connection for every device. That saves money. And using an internet connection lets all of those computers share information. Remember looking at web pages or doing text messages or email, that's all sharing information. So a network is defined, or I define a network, as many computers that are connected to one another. And you can see that the internet is a network because it's a network of networks because there are many computers that are connected to one another. There are many web servers all over the world and we access them all the time. Okay, so there's only a couple more things that I need to talk about. And that is hardware. I forgot to do the central processing unit, which is the part that's considered the brains of the computer, is the central processing unit. It does all of the arithmetic, it does logic operations, and it controls the flow of information from one part of the computer to another. In order to have faster CPUs, we've reached kind of a limit on how fast we can get a CPU to go. About 4 gigahertz is the fastest we can get one to go without it overheating and blowing up. Well, it doesn't really blow up, it just fries itself. So instead of doing that, we have multi-core processors. And really, we have dual-core processors, which have 2 processors on board, and also very common are quad-core, so 4 processors on board. There are others, 8 and 16, but they're not very common. In order to future-proof yourself, when you buy a computer, you should get, I bought a quad-core, but I wouldn't buy anything less than a dual-core. And the reason is because programs are going to expect computers to have 2-core processors or quad-core processors, and a lot of programs already do and can take advantage of that. So dual core processors. And by the way, the unsung hero of computers are USB ports. We use everything with USB ports. Oops. So this is a USB plug, right? And computers have ports, and we plug this in. We plug in mice and printers and scanners, if they're not wireless, using USB ports. Our phones have, well, this is a lightning, but on the other end, there's a USB plug. My camera has a mini USB port. So USB ports are how we typically connect things to a computer. And lastly, when you buy a computer, your main thought should always be what programs you need it to run. So when you go to research buying a new computer, you need to first figure out the software that you need it to run. I need it to run a video editing program. Why? Because that's part of my job, or because it's my hobby. And so that's what I want the computer for. So you need to tailor the hardware of the computer that you buy to make sure that it runs the software that you want. Otherwise, it's really not that useful, right? Well, I bought it so that I could do video editing, but it's not powerful enough, so I can't. You should have waited till you had enough money to buy, you know, the computer that you wanted. So let me talk about the test in general. Always go from software to hardware. So what programs do I need to run? That's the hardware that I buy, whether it's a laptop or a desktop or whatever. That's the main decision that you should make, is what software do I need to run? If you need to run Word or and you know, some regular programs, then it's not a big deal. But you should always keep in mind, hey, I need to run a particular piece of software. Will this computer run it? Otherwise, it's useless. Okay, so the test in itself will have 38 questions, I think. Most of them are 2 points, and there's one 1-pointer because it's worth 75 points total. You have until Sunday to take it, Sunday midnight. You have 1 try. The test time limit is 45 minutes. So you have more than a minute per question. That should be more than enough time. What else? There are multiple choice, true, false, and some pick the answer from the same answers. Make sure that you only use the answers once. It's the last part of the test. So you'll have different questions and you'll have just the same list of answers. Yeah, so there you go. That's the review for the test. Good luck. We'll see you later.